Okay, so I am Stuart Tausman. This is the first recording for the 4-week class. I'm just going to use this and then just upload it for the other people to use. We're going to talk about the concept on the agenda number 1, statistical significance. What do we know about it? What does it mean when somebody says you have a statistically significant finding? Does anybody know what that term statistical significance means? And by the way, if this is simple for some and not for others, if it's simple for you and you have a good answer, say it, because some people may or may not know it, but feel free to share. So what does that term mean, statistical significance?
So the difference is greater than the margin of error.
The difference is greater than the margin of error. So there is a margin of error due to maybe chance, and the difference is greater than that particular situation. Anything else? That would be part of it. What else? Statistical significance. Do we like statistical significance?
Yes.
Yeah, for a stat person, we like statistical significance. We don't like.
If it's in our favor, we like it.
If it's in our favor, if it disproves a hypothesis,
Yes.
we never say it proves a hypothesis. It's either supportive or non-supportive, because we don't like to prove the null hypothesis at all. What else do we know about statistical significance? Okay, well, let me start out then at this point. So let me give you, I think, my simplest real-world example of what that term means, because I think it's a very important term for you folks to understand. Let's say the idea of statistical significance, and if you do want to take notes on this, you're more than welcome to. There's not going to be any test, because we're all faculty and we're just doing teaching and learning here. But if I asked you the following question, and I put it up there, if I asked you, basically with statistical significance, you're trying to figure out, when you get a result from doing a study, was it due to chance or could something else have caused it? So statistical significance, we know a lot about chance in statistics. And what you're trying to figure out is this result due to chance or is it due to something else? Now in statistics, what do you think we want the answer to be?
Something else.
Something else is the nature of it. So let me ask you just in a hypothetical way, and we're not going to get political or meteorological too much here, but let's say there was one day next summer where it was 100 degrees here in Stanton, or this is Fishersville. Waynesboro over here? Where are we?
Fishersville.
Fishersville. So one day next summer where it was 100 degrees. And I said, is that due to chance or is that due to another variable? Climate change is your example. What would you probably answer for me? What would you probably say? One day.
Chance.
Chance, because that happens maybe once out of every 5-6 years. So what you would probably do is you would say, well, one day of 100 degrees, that could happen 20% of the time due to chance. So I'm going to say that's due to chance. Does that make pretty good sense for everyone? And you'll have to excuse me if I ask questions that seem really simple and stupid, because I've been working with a lot of undergraduates for the last 25 years. So, yeah, that's probably due to chance, because that could happen 20% of the time. But what if I asked you the question of, okay, next summer, up here in Fishersville, what if we had 30 straight days where it got to be over 100 degrees? Could that happen due to chance?
Could, but it's not likely.
It could happen due to chance. But what are the odds on that happening due to chance?
Not very high.
The odds are very low. So the odds of having 30 straight days of 100 degrees might be 1 in 1,000 years. So if we find that a result could happen 1 out of every 1,000 times, we basically decide that result did not happen due to chance. There must have been some other variable causing that to occur. And in this case, we'd probably say, well, if it was 30 straight days, the other variable might be a climate variable if you wanted it to be. So statistical significance, what's the key p-value that we always talk about in statistics? There's only one value. 0.05. So what we decide, and if you want to write this down, but you already know this, if the probability, if you write something is statistically significant, we always write p less than 0.05. And so the idea is, if we get an event statistically that due to chance will happen less than 5 times out of 100, we basically say it ain't due to chance. It's kind of like a double negative. So if an event happens and the probability of it happening due to chance is less than 5 out of 100, we say that ain't due to chance. That's due to something else. Your OT, your PT, your PA intervention. So we like probabilities that are less than 0.5. Does that kind of explain the concept of statistical significance? Do you guys want to ask any questions or comments about that? Please.
Am I wrong in thinking that in some studies, though, they sometimes use different p-values as their significance?
Yes, in some studies, you are correct. They use different values, and actually, let me just grab a little drink. It's a good question to be asked. Sometimes, let me go into 2 realms there. Sometimes we have what we call, with hypothesis testing, directional hypotheses. I think I told you guys, I'm an asthma guy, right? I like to run asthma education research. And I have worked, who's an OT in here? When I was running my projects, I actually used to work with quite a few, some OTs in the equation, that we always had a hypothesis that we thought our asthma program would help people. That's a very directional hypothesis. So sometimes we wanted to say, okay, we think the asthma program will work, and we would change things from being two-tailed to one-tailed. When things are two-tailed, you need to get a higher score when you run your statistics to be significant. But even when it's a directional hypothesis, which we all have, we usually keep things two-tailed, because what we don't want to run into is if something is significant one-tailed, there's a good chance that it might be a false alarm, that you might have a type 1 error. The other thing that is sometimes done is you look at p-values of 0.05, 0.01. It's harder to reject at the 0.01 level. What's nice about computer programs is SPSS will actually always tell you the exact probability of something occurring. And if it's if the probability is greater than 0.5, it is non-significant. Now, the final thing that I'll share with you under this realm of significance that you bring up is what happens if you run a study and you get a probability of 0.06. Statistically speaking, what would you have to say?
It's not.
It's not significant, because it's kind of the line in the sand. But if you want to write for your notes, one of the things we often use in statistics is the term, I like to use it, marginal significance. If you get a result that could happen, statisticians don't like maybes. This is the closest we got to a maybe in statistics. That if you get a probability between 0.05 and 0.099, we sometimes like to use the term marginal significance. We think there might be something there, but it's just not quite there yet. I can give you a simple example of that. Many years ago when we ran our first asthma study, we only had 7 people. And we got a lot of p-values between 0.05 and 0.099. But if you have 7 people, you don't have any power to your study. And so we had a lot of marginal significance. We didn't want to say this didn't work. We believed we had kind of a type 2 error, a miss there. Next year we ran the same study again and everything turned significant because we tripled our sample size. So p-values, 0.05 is kind of the line in the sand, but hopefully you better understand. Does that kind of answer your question and a few other things? Other comments or questions about
that? Are you going to talk at some point about the whole power issue and calculating power? Because when you look at the equations on doing all of that, some of it's a crapshoot because you have to guess on some of the where
Yes.
you think they're going to be, and it's really difficult.
I can comment on that right now. I don't know if I had any specific lecture going into that, but the power analysis, what I use and what most statisticians use is called a G-power program. And what you have to do, and I have it on my system, before you do a study, you want to try to figure out how many people will you need to get a significant result. And what you need is to get past research that says, here's what we think the treatment effect is going to be. Here's what we think will happen when we run this. And if you know that, then you can basically, it's very easy with the G-Power program to plug in a few things and say, power we almost always want in health research and psych research, 80% power. You plug a few things in and it says you need 40 people. So we usually like 80% power. You put information into the computer. You have to use previous research to estimate kind of the probable treatment effect that you might have if you do what you're going to do in PT, OT, or PA to cause an impact. And if you do that, you can guesstimate, here's how many people I'll need to have what we call a hit, where you say it's significant and it really is.
Well, how generalizable does those previous studies have to be? What if it's something pretty new and there's not a lot of data on it?
Then it's more difficult to do in that particular way. You have to, the other thing that G-Power can do for you is you can say, I expect a very small effect, a small effect size, a moderate effect size, a large effect size, but it is just a guesstimate. So power estimates, usually done by doctoral students, can be done to try to figure out, you look at the past research, and you say, here's what I expect to occur here, and then you can plug all that in and it'll tell you something. Many times when you run the study, you don't get enough anyway, but you do it.
Increasingly, our PT literature and our well-respected peer-reviewed journals have an expectation that you've done a power calculation, otherwise they won't even look at it.
So part of what I've been helping out some colleagues with around here is if you need to do that, that's something that I've been doing some consulting on, that we can sit down and talk and look at some of the articles and try to guesstimate, and then my role as a statistician can say, well, a statistician looked over this and we estimated a treatment effect of a moderate size and 80% power, and we put it in. Actually, I did that with one of the one of the Mary Baldwin psych students, and we came up with, here's how many people we need to have to get this amount of power. 80% power is usually the general accepted norm of what you want in those situations. But you're right, it is a guesstimate, and you kind of have to know things about some standard deviations sometimes and treatment effects, and sometimes we just don't. Other comments or questions? These are good thoughts. Okay, so we kind of covered number one. Okay, I'm going to change. You might have the agenda before you on the articles, but I wanted to, actually, let's stop this thing.